Welcome to Algebra 1, Unit 7, Lesson 4.3, Solving Inequalities Using Multiplication and Division. I'm Mr. Pi, and our objective today is I will be able to solve inequalities with multiplication and division. I work out of the Pearson Algebra 1 Copyright 2009 textbook. Taking a look at this objective, it should be familiar to you. You should be just coming off of a Lesson 4.2 on solving inequalities with addition and subtraction, and being that you're in an algebra class, you should be familiar with solving equations. This is just like solving equations, except for a few little minor adjustments when multiplying or dividing by a negative number. So let's take a look at these properties and then some problems. Here we have a property of algebra, property of math, multiplication property of inequality for c is greater than 0. Well, for c is greater than 0, that means c must be a positive number. So this is really for positive numbers. So let me interpret some of that there for you. That's what that means. For every real number, a and b, and for c greater than 0, if a is greater than b, then a times c is greater than b times c. We see a numerical example here. We have 4 is greater than negative 1. We, of course, know that is true. When we multiply both sides by 5, it is also true. That would give us 20 is greater than negative 5. In this case, we have if a is less than b, then a times c is less than b times c. Here we have the numerical example to help us understand a little bit better. We know that negative 6 is less than 3, so if we multiply both sides by 5, that less than remains true. In fact, we can see that. That'd be negative 30 is less than 15. And of course, you should know that is true. So in other words, when we go to solve inequalities, to maintain that balance in the equality, we must multiply the same number to both sides of the inequality. Example 1t, we'll be multiplying by a positive number. We're told to solve the following and graph the solution. So we have two examples to do here. Example A is x divided by 3 is less than or equal to negative 9. Of course, on the left-hand side, you see the variable x. And to isolate that variable or get it by itself, we have to get rid of divide by 3. And to do that, we're going to multiply both sides by 3. On the left-hand side, if you don't understand what's going on over here, I tell my students a lot of times that if you put a 1 there, you can imagine that these numbers cancel out. They divide. In essence, this becomes 3x over 3, and the 3's can reduce. So that leaves us with the variable now isolated, x. We bring down the inequality sign as the middle, and negative 9 times 3 is negative 27. When you go to make a graph of this, it doesn't have to be anything complicated. If you're already given a graph with numbers on it, a line, that makes it so much easier. But if you're not, what you have to do is just number the graph, and what I normally do is put the negative 27 in the middle. I just use 3 numbers. On the left-hand side, I put a number smaller than that, negative 28, and on the right-hand side, a number larger than that. And then I make my graph based on the inequality. Here we are solved for negative 27, and it's an equal sign, so that means there's a closed circle on negative 27. And since it's a less than symbol, numbers that are less than negative 27 are to the left. So we would shade in or darken that half of the number line. In example B, it's a little bit different example. We have a fractional coefficient here. We have 4/5 times x is less than 14. A lot of students, because this is times here, want to divide each side by 4/5. And if you know how to do that on a calculator, that's perfectly fine. Okay, that's okay, but if you don't have a calculator and you need to do it by hand or show some work, what you would want to do is multiply by the reciprocal of 4/5, which is 5 over 4. The reason we do that is that the 5's will cancel out, they'll divide out by a factor of 5, and the 4's will divide out by a factor of 5, and that becomes 1, leaving the x now isolated on the left-hand side. On the right, we multiply by the same number we multiplied over here, 5/4. Now, when we do this math, we can multiply fractions numerator to numerator, then denominator to denominator, and then reduce the fraction. Or you could reduce beforehand by using a technique called cross-canceling. 4 and 14 have a common factor of 2. So I can divide 2 out of 4, and that leaves a 2. I can divide 2 out of 14, and that leaves us 7. So now, instead of multiplying 14 by 5, I'll multiply 7 by 5. 7 times 5 is 35. And then in the denominator, I'll multiply 1 times 2 to give 2. So we solve that x is less than 35 halves. Now, that number, if you're not quick with math, doesn't make a lot of sense to you, so it's always a good idea to change it to a mixed number or a decimal. And changing this to a mixed number, we divide 2 into 3 one time. That leaves 1 left over. So we divide 2 into 15, and that goes 4 times with 1 left over, so that'd be 14 and 1/2, or 14.5. So x is less than 14 and 1/2. So that'll be the number in the middle of my number line, 14 and 1/2. The next number up here is going to be 15, and down here is going to be 14. So just graphing it by units of 1/2. So now I go to shade the number line. The number I solved for, 14 and 1/2. We're going to use an open circle because of the less than symbol. There's no equal sign there. And since it's a less than sign, like example A, we'll shade or darken in the left half of the number line. Here we have our second property of this video algebra lesson. It's the multiplication property of inequality for c is less than 0. What that means is we're working with negative numbers. So when we multiply each side by a negative number, we have a special rule that applies. For every real number a, b, and c is less than 0, if a is greater than b, then a times c is less than b. I want you to notice that change right there. The inequality switches around from a greater than symbol to a less than symbol. And if we take a look at it with these numbers, 4 is greater than -1. So when we multiply both sides by -2, we end up with -8 and +2. And to maintain the inequality, we have to switch it around. If we leave it, it's not true and it's not going to be solved properly. Over here we have, if a is less than b, then a times c is greater than b times c. So if we multiply both sides by a negative number, we switch a less than symbol into a greater than symbol. With numbers, -6 is less than 3, which we all know is true. When we multiply both sides by a -2, we have to turn it around to a greater than symbol because -6 times -2 is a +12. And that is greater than -6, which is given by 3 times -2. We can see here this property also applies to the equal part of that, greater than or equal to and less than or equal to. When we apply this to solving inequalities, we can say, in other words, to maintain the balance of the inequality, you must multiply the same negative number to both sides of the inequality and switch the inequality. So unlike anything you've done yet, you need to switch the inequality to maintain it when you multiply each side by a negative number. Example 2, we'll be multiplying by a negative number. Here in red, I just remind you when multiplying by negative numbers, you have to switch the inequality. So let's take a look at example A, where we're told to follow the following, or solve the following, and graph the solution. Little Twitter slip there, follow the following. No, that's not going to follow anybody on Twitter today. So here we have x divided by -6, that's greater than -4/10. So what we do, recognize that this is division by -6, so I'm going to multiply each side by a -6. The -6 on the left, remember they divide out, they cancel, leaving us with 1x on the left-hand side. Since I multiplied by a negative, I turn that inequality around from greater than to equal. Then I multiply these two numbers. A negative times a negative is positive, and 4 times 6 is 24. And since 0.4 has one decimal place in it, we have the number 2.4. So graphing this, 2.4, the number we solve for, goes in the middle. To the right, I'll put 2.5. On the left, I'll put 2.3. Recognize that this is a less than symbol with no equal sign, so we'll use an open circle, and then we'll shade in or darken to the left. And looks something like that. With your pencil, I'm sure you'll do a much better job of darkening it in, but you get the idea. In example B, again, we have a fractional coefficient. It's a negative fractional coefficient, so remember that's going to affect this inequality. So to get rid of this fractional coefficient, we multiply both sides by its reciprocal, which would be negative 3/5. The negatives on the left become positive, and the 3's and the 5's all cancel out. That leaves us with x on the left-hand side isolated. On this side, I multiply by a negative 3/5, the same number as I did on the right. Since I multiply both sides by a negative, the less than becomes a greater than, and now I multiply. I can't cross cancel anywhere, so I just multiply straight across. 22 times 3 is 66. 1 times 5 is 5. And a positive times a negative is a negative. As I did before, in example 1, I'm going to convert this into a mixed number so it's a little bit easier to graph. So, changing this to a mixed number, 5 goes into 6 one times with 1 left over. 5 goes into 16 3 times with 1 left over, goes in and gives 15, so we subtract, so that gives us 13 1/5. So x is greater than 13 1/5, so that'll be my number in the middle. On the right, I'll put 13 2/5, and on the left, I'll just put 13, because that'd be 0/5, or just 13. Open circle, because there's no equal sign there, and I'm going to shade to the right, because I have a greater than symbol. So we'll darken that in. Here we have our third property in this video lesson on algebra, the division property of inequality. For every real number a and b, and for c greater than 0, if a is greater than b, then a over c is greater than b over c. In essence, what we're doing here is we're dividing each side by c. As we've seen with multiplication, addition and subtraction in inequalities, and with solving equations, whatever we do to one side, we do to the other. And we can see when we're working with positive numbers, the inequality stays the same, just like it did with multiplication. Here, for every real number, a and b, and for c less than 0, talking about negative numbers now, if a is greater than b, then a divided by c is less than b divided by c. Notice again, we changed the inequality. So whether we're multiplying or dividing by a negative number, we have to change or switch the inequality. The rules of division are the same as multiplication. Whatever you do to one side, you must do to the other side. Remember, if you divide or multiply by a negative number, you must switch the sign. In example 3t, we'll be dividing to solve an inequality. We're told to solve the following and graph the solution. Part A here has us solving negative 4x is less than or equal to 72. To do this, you should recognize that this is negative 4 times x, so you should use division to solve this inequality. When we're dividing, negative 4 and negative 4 on the left-hand side, they divide out, leaving us with the x or 1x now here. Since we divided both sides by a negative, we need to switch the inequality. Then we just complete this division over here. So we're going to have a negative answer because it's a positive divided by a negative. And then we do 4 divides into 7 one time, with 3 left over, and 4 goes into 32 18 times. So what we have here is x is greater than or equal to negative 18. Again, we had to switch the inequality. To graph this, it's going to be a closed circle on negative 18. Over here, remember, 1 greater is going to be negative 17, and 1 less than will be negative 19. And as I said, it's going to be a closed circle, or a circle that's been colored in or darkened in, and it's a greater than symbol. So numbers greater than negative 18 are to the right. So we darken or bold that up a little bit. In part B, we have negative 2/10 x greater than 9.6. So again, it's multiplication. So we'll divide each side by a negative 0.2. The left-hand side, these negatives divide out, leaving us with x. I changed the inequality again because I divided each side by a negative. 9.6 divided by negative 0.2 will be a negative answer. When I divide this, I have to multiply both of these numbers by 10 to make this the number 2. 2 goes into 9 4 times with 1 left over. And 2 goes into 16 8 times. So answer here, x is less than negative 48. Putting numbers on my number line, I'll start with negative 49. In the middle will be negative 48. And on the right will be negative 47. This will be an open circle because there is no equal sign in there. And since it's a less than symbol, we will shade to the left. That's a pretty sad looking arrow, but I think you get the idea. So there's using division to solve an inequality. Example 4. We'll be looking at a real-world problem-solving situation. Let me just point out to you that not necessarily in real life are you going to write a formal inequality to do this, but since this lesson is about inequalities, I want to show you how you could write an inequality for this family situation. It says your family budgets $160 to spend on fuel for a trip. How many times can they fill the car's gas tank if it costs $25 each time? What I'd like to mention here is this idea of rise. We're going to read the problem, we're going to illustrate the problem, we're going to solve the problem, then we're going to write a short explanation. This is really useful for open-ended problems in any type of standardized test. So let's go back and read the problem, highlight some important information. It says your family budgets $160 to spend on fuel for a trip. Here's the question. How many times can they fill the car's tank? And then here's another important piece of information. If it costs $20 each time. So a part of the read, what I like to put in there is some important information for my read. That they would have $160 to spend. That they have $25 each fill up. That it costs them $25 per fill up. And then actually then state the question itself. How many times can they fill the tank? And what this reading portion does, help you analyze and take time to try to understand the problem before you solve it. Now, illustrate. A couple ways. If you're artistic, you can illustrate it that way. If you're more mathematical, you could illustrate it with an inequality. I'm not very artistic, but I could imagine that maybe you could take draw a big sack of money and maybe put the 160 on it, and then you draw a picture of a car or something, and you put 25 on it, indicating that'd be 25 per time, how many times you could fill the car. I'm more mathematical, so I see this in a more of a mathematical way. And the question being, how many times can they fill up the tank? How many times can they fill up the tank? We need a variable for that, and x would be equal to the number of fill-ups. And then I'd start piecing my equation together. The whole in this case is the $160 to spend. That's the whole amount. That's how much money they can spend in total. So the $160, I'm going to put that over to the right because that's what we're going to end up cutting up. And it costs them $25 to fill up the tank. What we need to solve for is x. And in this case, anytime you have this and it says each time or per fill up, that indicates some kind of multiplication relationship. So $25 for one fill up times the number of fill ups. Now this number has to be less than or equal to how much money they have to spend. So the inequality symbol that goes in here is less than or equal to. If it costs them $25 per fill up, how many times can they fill up the tank? It has to be less than or equal to the total, the amount of money they have. In the solve portion, what I would do is solve the inequality. 25x is less than or equal to 160. Now, we divide that, both sides of that inequality by 25. The 25's on the left, divide out, leaving x. I bring down the inequality. Notice I did not change it because I'm divided by each side by a positive. And 160 divided by 25, well, that goes into there 6 times. 6 times 25 is 150, and that leaves 10 left over, 10 over 25. That you can change that to a reduced fraction, which would be 6 2/5. Or if you're so inclined, you could write that as a decimal number, 6.4. So then for an explain portion, we kind of explain what that solution is. The family can fill up 6 full tanks. Now, it doesn't say anything about that, but they can fill up 6 full tanks. They can fill up 6 times. 6.4, not exactly a correct answer, and I interpret that because of the way they word this here. How many times can they fill up the tank? So assuming it's close to empty, how many times can they fill it up all the way? They can fill it up all the way 6 times. So there's problem solving with this idea of RISE, where we read, illustrate, solve, and explain the problem.